the company update?
So we launched the Chestnut. Pretty big success. We sold 397 of them. So yeah, it was about it was pretty much exactly what we forecasted. We sold more ready to drives than expected. So most people bought the ready to drive edition, which is just the edition that includes 9060. I drove to San Francisco and back this weekend on an eGPU. One minor model lagging, but otherwise totally stable. And the model lagging was just I couldn't engage for 10 seconds. So seems to be working pretty well. AMD sent us 2 MI350P cards to play with. So hopefully we'll get those put into a computer today. MI350P is half an MI350X. So it's a pretty nice little PCIe card.
The P stands for PCIe?
Yeah, sure. That sounds right. So yeah, my 350Ps. We need to talk about CI stability.
Yes.
I reverted HTTP2. We can't have this. But you know, it's harder to rail now about CI stability when GitHub is down. You know, you just kind of can't believe. So yeah, or it can move off GitHub. But yeah, no, there was CI instability caused by HQ2, and yeah, we can't have that because it makes it really hard for everybody else in the company to work when there's. Yeah, that's pretty much it. But yeah, Chestnut launch was a success, so we can expect more noobs in the Discord complaining about their Chestnut not working.
Oh, we have a channel for that?
GPU USB, GPU on USB.
That's not Chestnut. I think people probably will complain Commas Discord.
If I connect a NIC to the Chestnut, it should fall back to PCIe, right? I don't know. It's not supported.
Yeah. Okay, we'll see. I think they will report to Calm if they are not happy.
Yeah. Well, I mean, the firmware, we're kind of the ones maintaining it. But
Cool. Sounds good. Okay. Let's move on. We can start with HCQ2.
Yeah. So related to DCI, like HCQ2 is back in CI for a couple of days, and it's I fixed the so the race, so it should be stable now. So also CPU is full HCQ2 now, and also I merged today, so we just sent one CPU program for like all HCQ kernels, like different backends, and just no matter what.
Yeah, I see a big boost to tokens per second.
Yeah, and I have another patch to, once GitHub is fixed.
Yeah, I mean it's not back to where it was yet.
Yeah, I have another one to make it a bit better.
Yeah, I mean if you look at that Quen MOE on the right there, yeah, we want to get that back to. I mean, you can really see it if you zoom out one more. Like I think probably that's the one to watch.
Yeah, so it was 150. It's 100 right now in master, and I have a patch to make it 120. So yeah, I'm looking into that.
Yeah, why is it not 160? Why is it so much slower?
So I'll look into that. But mostly we had like the main speed up was like we had uncacheable programs, so that was the performance issue, and the other was like the Python time.
Yeah, I mean, there shouldn't be too much Python time unless we're doing something pretty bad. I mean, that should be in a JIT entirely.
Yeah. I'll look into Quen. So I just have CFAR, right? Like much in HCQ1 speed. So yeah, Quen is the next one
Got
for me to
it.
look into.
Yeah, see, I mean, CFAR, I don't see much of a difference in at all. Oh, I guess the CFAR 6 GPU. Is that what you're talking about?
Yeah.
And that one
So
still
actually,
seems a lot.
it's not in master. I mean, I
No, no.
have a pull request. Yeah, I'm just waiting for GitHub.
I got it. Yeah, yeah. But cool. Yeah, no, I mean, the instability is much worse than a bit of a slowdown.
Also, the time to run benchmark is very slow. Some of it is like Beam is slow, but also MLPerf training 6 ResNet on 6 GPU is also pretty slow. Slow as in like 10 to 15 minutes. We know what's happening.
Yeah, so yeah, I'll look into that. So something degraded because it was like the first step was faster than it's right now.
Yeah, so yeah, just focus if it's SCQ2 related, because I also try, because metal beaming OLMOE is also very slow, and I think half of that time is something with symbolic being slow. So that's not really HCQ2 related, but I was tempted to reduce the JIT beam to like 1 or something. Otherwise, this takes forever.
I mean, people are just saying Beam in general is having issues.
I can believe that.
Yeah.
I mean, maybe not issue, but just very slow.
Yeah, I mean, Beam's some of the oldest code in Tinygrad. Like, we have to write it in a new style. I've been thinking about how it gets changed.
Yeah.
Like, it should pretty much be a graph rewrite. We also want to parallelize the lowering and the compilation in general, I think.
Yeah. Anyway, that would be nice. Otherwise, benchmarks very slow.
Yeah. No, I mean, is it an HEQ2 regression or is it just slow?
I don't remember this being this slow a week ago, so it might be some
Yeah,
thing, someone, including me, merged that we just didn't aware, and it adds up.
Can we have this in Tiny Stats? Why don't we have this in Tiny Stats? How long benchmarks take?
Yeah.
Great.
Okay, sounds good. Anything
Yeah, I
else?
want you to
for-
track. Because I'm going to track the CI.
Cool. Anything else for HCQ2?
yeah. So not for HCQ2, but we also have like the Broadcom driver working.
Right.
So yeah, I'll clean it up. It's probably not my focus. So this week I'm still focusing on the HCQ1 removal. So the remaining steps is they use B for AMD. I mean, all the speed regressions, then use B, and then NV and QCOM. So yeah.
Cool. Yeah, are those machines working well?
Yeah.
Cool. Sounds good. Anything else?
No.
Okay. Moving on, GPT OSS. I just saw around that's like 1.2 seconds.
Yeah, we're at 1.2. We're just above 1.2. The machine does slow down quite a bit. So at the beginning of the run, we're at like 1.18, and then it goes up to 1.22 almost by the end of the run.
Is it the same?
Yeah, it's the same as the llama slowness.
Got it.
From the throttling. But this puts us at 4 hours 30.
Yeah. Also, yeah, but all the slowdown is right at the beginning.
Yeah.
Great. 4 hours 30. All right, cool. So
Yep,
how
this
are
is
we?
1. Yeah.
Oh, we're already at 1.2. Oh, that's great.
Yeah, this is 1.2 from just, I switched from 0.1 to 0.2, so the grads are also sharded now. And this saves a bunch of calm. This saves a bunch of calms. And then this also is just the flash attention sliding window fix, so that we don't have to recompute.
Right. Yeah. So
why is the total time 4.5 hours, just 1 hour shorter when the step was like twice?
Step dropped 400 milliseconds.
Oh, I see. Okay.
Yeah.
And this is
Also
in master?
looking, not yet. So that's what I'm doing this week. There's a bunch of stuff to clean up, and then just to merge into master.
Cool.
yeah, the time all checks out. I mean, it's a little bit slower.
Yeah.
I'm seeing it's 248 minutes if you just multiply it out. So there's like 20 minutes of overhead or something.
Yeah, the first steps take a while.
Yeah. But that's not. Don't worry about that. We will fix that. We can also always just pre-cache it, but cool. Yeah. So it seems like we're on track for that.
Yep.
Keep it up. Let's get to 800.
Yep. And I guess I'll use this to talk about some infra stuff too, since I've been working on some of that as well. We should hopefully have CI/CD by this week, so infra will just deploy automatically once you push.
Got it. So you're moving tiny infra into CI.
Yes, basically the gateway will have an actions runner, and then when you push, that actions runner will deploy.
Cool. Yeah, I mean, I think maybe you want to also move our infra into Gitya?
Yeah, I was thinking about that too after this morning, GitHub being just down.
Yeah. I think Gitya is. I mean, it's not great yet, and we still have to come up with a backup strategy, a strategy to back up Gitya. But otherwise, I like it. I mean, it's just so much faster. Just go to git.tinygrad.win now and click around. Like, it's unbelievable how slow GitHub is.
Yeah.
And the PRs do like a dry run deploy or something like that?
Yeah, we can do that.
Yeah, that makes sense. I don't really know exactly what dry run does.
Just something to make sure that you didn't like screw
Yeah.
something.
We just show you the deployment action before you actually merge
Yeah, the
it.
main deploy script already will do a dry run before to make sure nothing's broken before deploying.
Cool.
Great.
Good work getting good work getting Tiny R8 back. So Tiny R9, can we have something so it doesn't wipe itself?
Yeah, I fixed that. Just the takeover script was missing a check to see if there was an OS on the drive.
Okay. Yeah, it wiped 2 hours of LLM progress, but not that big a deal.
Yeah, that should be fixed now.
Is the MOE plan in GPT OSS channel still accurate?
Yeah.
Because it looks like 0 gives you more than estimated.
0 gave me less than, well, it gave me about what I expected from estimated. Because 0 is not the full comms fix 2.
I see. I mean, you know better. I'm just curious how much of this speed up follows as compared to the actual speed up.
Yeah, it's about what I expected.
Cool. Great. Anything else?
Nope.
Okay. Moving on to Llama.
I'll share my latest run is 130 minutes. And AMD did in our machine in 127. So we are 3 minutes
What?
left.
What's the purple run?
The purple run is currently running. I think it should finish faster than this one. I can explain each of these. The blue line is assembly for VF16 gems. And the purple line is a forward flash attention in assembly. There is still a backward that they're faster than us. I think if I get a fast and correct backward assembly, we should be on par.
Cool. So you said AMD got 2 hours and 7 minutes on our computer.
Yes, 127 minutes.
That's great. All right, so we're almost there. How much of this is merged to master?
I'll start merging the custom kernel stuff, and then I'll have to really take on a project to figure out how to express the overdue stuff.
Yeah, I'm less worried about the custom kernels and the assembly. I'm less worried about than all the complexity I saw for the all reduce. Are you using HEQ1 or HEQ2?
Oh, that's HCQ1.
Nimmelgen, do you think HEQ2 should be ready?
We just need all like several SDMAQs.
Got it. Yeah, no, I mean, as soon as we can, we want to move this over to HEQ2 and make sure we're working on the newest stuff. Yeah, so you're doing what is your communication stuff on the branch that's hard to merge?
It's basically for using subbuffers in all reduce.
Oh, that's not that crazy. Yeah, that
It-
should be merged. I mean, it's crazy if you're doing like the 2Q thing, but if it's just subbuffers.
yeah, it's just subbuffers, but then you realize there are issues in the memory planner, and then there are subtleties with how you want to express things cleanly, especially that now we don't have slice anymore. I kind of dabbled with like expressing it with the shrink and like tagging the UOP. It needs a project to figure out how to do right. I'm not happy with having stuff in a branch either.
No, we shouldn't need a tag. I mean, shrink should be fine. If there's problems in the memory planner, then they just kind of need to be fixed. Yeah, I mean, it's hard. What, you're worried because of the like asynchronicity between the queues?
The idle stuff. Well, those are actually a problem, and if we want to beat AMD, I should fix the idles.
Wait, I don't
But
even
that's
know
a
what the
separate
idles
issue.
are. I just meant like, what's the bug in the memory planner?
Oh, the bug in the memory planner is just like freeze up the underlying buffers. Yeah.
It frees the target of the communication before it's ready. Yeah.
Yeah.
I mean, yeah, that stuff. The way that we finally want to express all of this is like, I think the way to start thinking about copies is like right now we've kind of special case this whole SDMA thing, but it really shouldn't be a special case. So we have to move to this concept where where the compute runs and what device has the memory are completely independent. So for example, you could imagine a computer with 2 GPUs. But you could imagine the memory all being on the first GPU, but then the compute kernel running on the second GPU. Now, this is dumb in practice because your PCIe is going to be a lot slower than your memory, but Tinygrid needs to be able to express this. And then, once it can express this, the SDMA is really no different from a compute engine, except that it can't express ALUs. So, like right now, we've already moved to this architecture where it's a very late transformation that transforms like the kernel
Or to
back
copy,
to a
yeah.
copy. Yeah. So, I mean, I think that should just be made more generic and like think about how to do that. Think about how to separate the idea of what where this kernel runs versus what memory this kernel accesses.
Yeah. I mean, the ultimate thing is not having this DMA at all. Just
But I wouldn't worry
lower
about
the
that.
kernel.
That's even harder, right? Like I would make it like so it shouldn't even matter where the thing runs. Right? Like we should just be really, really good at expressing yeah, we can run this kernel on SDMA, we can run this kernel on the compute kernels. Yeah. I wouldn't try to remove SDMA as much. It's like, is SDMA still causing slowdowns? What are the idles that you say we need to beat AMD?
Well, the idles are caused because the add kernel, the ALU, the STM is incapable of running ALU, right? So the add kernel stalls because it's waiting on an SDMA to finish, and no other compute can run because we only have one compute queue. And this
Yeah,
can be partially fixed by messing with the tuple sort.
I think it's all the topo sort. I think we've talked about this before, and I think all you need to do is topo sort those ads to happen after next backwards.
Yeah, I think that's what I will focus on.
Cool.
Yeah.
What's
What?
AMD's real time on the ML perf board?
Oh, 110 minutes?
110 minutes. You think we can get to 110 minutes even with our crappy computers?
No.
Why not?
It would require like below 1 second. I haven't even counted.
Do you have like a breakdown of like where the time is now?
Our time? Oh, I think if I get flash attention to use their assembly, we should match. Because right now it's like only 3 minutes, 3 to 2 minutes off.
I mean, it looks like you got an even faster run going right now.
Yes, it's unfinished. Actually, finish faster.
It seems to be like
Yeah.
creeping upwards, which I don't really understand, but
Creeping upwards. I can share
Warmer
the
outside.
link.
you're right.
Minutes.
If that's running right now, it's actually probably because it's getting warmer in San Diego.
Yeah.
That link doesn't work for me. But I don't know. I
Interesting.
clicked on the thing and I can see it.
Interesting.
I click on the who knows.
Wait,
WANDB was trying to get me to pay them money. Wow, that's because it's getting warmer in San Diego.
Could be.
No.
We need the perfect
Just
day. We need
divert
a
the
nice.
very cold very cold air from the office to the data center or something.
Oh yeah, yeah. Well, there's those two rooms that are really cold. We can just pump that cold air down there. I mean, do you think it's possible to beat AMD's time even with our?
With our computers.
Yeah, like what's the best we can do?
What's the best we can do? I think once I finish our assembly kernel moving, the opportunities are making the assembly faster and making our communications better than theirs.
How much would we get like right now if we had the communications copied from theirs? Like the way they're doing it with the 4 CUs.
It's not actually quite perfect, the Rockwell stuff.
Yeah.
still has stalls. They only have like half our stalls, so they still have like 55 milliseconds-ish, all stalls. We have 100 milliseconds.
We have 100 milliseconds of stall. So if we could get rid of the
Yes.
stalls, we'd be at 1.1 pure compute.
We're already at 1.1. Would be lowest. I think below
Yeah.
1 second. If you have like the perfect.
Right?
Yeah.
1 second. Wait, what? No, that's not right.
Is the cloud stuff out of the question?
Yeah, that's a backup plan.
Mm-hmm.
The cloud's a backup plan. I don't know. We waste a lot of money on that, and I think we can do without it.
Oh, by the way, like I fixed the Python time and I merged the bug fixes in master, so now we have half the step time now done.
Oh, great! How much time are we just wasting in startup on Python?
Right now it's 3 minutes. Our first step happens in 97 seconds. The rest is because we serialize the data loader. So if I parallelize the data loader, I think we can get even faster startup.
Interesting. Step time. Okay, so what step is this?
For 3 minutes now.
Oh,
And it was 6 minutes.
well, that's a waste. That's 3 minutes we're wasting.
97 seconds of it is.
Wait, if we can get
scheduling.
1 second, we just beat them.
Okay, 97 seconds is scheduling. I can look at the data loader.
Don't worry about that for now. That's time that we always know that we have. Let's just focus
Yeah.
on getting rid of all our stalls. So if we get rid of all our stalls, we're at 1.2 right now.
We start at 1.12 and
No,
we stabilize at 1.2.
We can't rely on what we start at.
Okay, so we stabilize at 1.22.
It was at 1.22. Okay. We need to get to 1.06.
1.06 stable.
Yeah.
I'll get the breakdown, see if that's possible.
Great. Yeah, if we can just get to 1.06, you know, we can say that, oh, our computer should be colder, but I don't know. I think that there's so much room to still improve. And then of course, you know, for our final runs, maybe we can use cloud. But I think we should just beat AMD straight up here, even with
Yeah.
even with our warm computers.
Even with our very hot computers.
Yeah, well, yeah, at nighttime, you know.
Yeah.
Cool.
I think for cloud we would need our driver support. I don't know how easy that one is.
I would, yeah. Let's take cloud off the table. I've now wasted $120 on cloud with nothing to show for it.
Yeah, that timeout, I'm not sure how to debug it, but yeah.
I don't know how to debug any. Do you really want to deal with like something that's just totally out of your control? Not really.
Yeah.
We can deal with things in our control. I think the more likely thing to happen is that we're going to get an air conditioner for here.
Cool.
But if we can just hit 1.06 seconds, that's the best way to do it.
I'll work on the hot machines. Yeah.
Right.
Sounds good. Anything else?
That's all.
Okay, moving on. Ranger flag.
Yeah, so some progress there. I got rid of bind. So now the variables are just treated like any other any other buffer. They just have a different address space, which really simplifies new Rangeify. You don't have to deal with any special casing for variables. It's passing most tests. Still a bunch of failures on the new thing, and then like I also want to like kind of change the behavior of contiguous. Currently contiguous will be transformed and given a buffer and qualify, when I think it probably shouldn't. You can just stay contiguous and qualify, meaning that that buffer won't make its way back to the tensor graph. If you do want a buffer in the tensor graph, you have to use clone. So clone actually creates like a numbered buffer, like a unique buffer. And then contiguous won't do that. Contiguous will still just be a kernel break. And then contiguous and stage are the same thing. So yeah, that'll kind of be my next deletion. Like contiguous at a high level, we'll just insert a stage at a lower level that says stage this in global memory. But yeah, no, a lot of progress on simplification there. Stage is here to stay. Stage means create a buffer and store while ending these ranges. And you can also do partial staging of stuff, which I think should let us express all kinds of pretty much everything. It's just like stage is just like the buffer creation, range end, all in one thing. And then stage is also like you can see a variant of stage. Maybe this is something else that also does multi. So right now we do multi by pushing multi through movement ops. But once we have new Rangeify, we should move away from this. We should make it so it's more like a restriction, It says basically that like this range, whenever it makes its way to the multi-op, needs to be on this thing, right? And that thing might be a device, that thing might be a warp, and then it'll rewrite the ranges that are lower down in the graph, and sometimes it'll say, "Sorry, this is invalid." But yeah, so new Rangeify is coming along. That's the first step. It's clean slate Rangeify. Oh, GitHub is back. Look at that. Yeah, so hopefully the new Rangeify makes sense. And you can see the to do in there, to do merging and splitting algorithm. So what I realized about all of the merging and splitting was like we do it in a lot of sort of ad hoc places right now. And we probably don't want to do that. We probably just want like an initial pass, which you can read this like add safe stages to never duplicate compute in that PR. And yeah, what that does is add stages such that no compute will ever be duplicated. And then the merging and splitting can happen later on to decide if we want to duplicate some compute. Or there's even some that resolve to not be duplicated compute. And those are just safe to remove entirely. Like that's kind of like a ReLU, right? Because a ReLU right now has children. A ReLU will go on one path to a where and another path to a, one path to a compare, one path to a where. And because that has children, you can't know when you're doing Rangeify if those children are going to resolve to the same ranges. But so we just put a stage in there and then remove that stage later. Then also the other thing that this can do is like, so we did a bunch of refactoring on the custom kernel to not have user contiguous, but the real solution is just to at the very, very end say you need to split before custom kernels. Right? That's just a rule. That's like a correctness rule. So you need to have a true buffer there. So but we can add that as a rule and not as something that needs to be like vaguely maintained throughout the thing. Oh, don't let it mess it up. Right, like that kind of stuff. Oh yeah, that is Rangeify 2. And Rangeify 2 deletes both Rangeify and indexing. There's no more indexing. Yeah, there's just Literally, it just, yeah. You take a store that has a shape, you throw 2 indexes on it, and then you migrate those indexes up the graph, eating all the movement ops as you go.
Sounds good.
I'll add stage to the spec because that one's here to stay. And then the other thing that I've been working on, casually, is the custom mech. It's private now. If you're on the
Yeah, that's not gonna
it worked. Forgot it. It's private now, but if you work here, you should be able to see it. It's a fully working custom mech. Which the thing that I really like about it is it shows all of the real things that the GPU is doing. Like there's no like what's actually happening when the GPU dispatches things. Kind of getting things set up for writing our own operating system. We don't need to rewrite the Mac. For our operating system, what we'll end up doing is we'll just dispatch like 96 long-running kernels, and those long-running kernels will handle everything.
Interesting.
Yeah, no, I mean, what we really want to do is we want to like the Mac and stuff's not a big deal. We want to replace all of this GPU dispatch machinery with local dispatch machinery that just runs on the cores. And once we have that, we can. I mean, that's pretty clear to me what future hardware should look like. Like they should just be independent cores that have their own communications primitives, because you're going to have to deal with your independent cores having their own communications primitives at the next layer up anyway. If you think about it just from like a multi GPU perspective, there's no dispatch across multi GPUs. There's no mech that spans. In fact, there's not even a mech that spans the entire MI300. There's actually 8 mechs. So
Cool. This is Kimi.
yeah, this is Kimmy, yeah.
He's pretty good.
It's pretty good, yeah. It required a lot more prompting than I would have liked. And this is all.
Yeah.
I've probably spent like 100 million tokens on this. This is also a distillation of like the first shot at this. Like it built this whole custom mech in Tinygrad that had so much complexity, and I'm just like, get the minimum stuff you need at this.
Great. Cool. Anything else?
Oh, gotta add stage to spec. Stage is real.
Sounds good. Okay. Next is my stuff. So, one const to have weak D type. I have made a good progress now that right before the D type decomp, every const has weak type and weak type only. So I remove all the strong D type const before the decomp and making sure everything still runs correctly, because there were other codes that depends on the strong D type, but now those are very clean. I have a PR that is biggish, works for metal and clan and the C style stuff. That's making sure the rest of the flow are the const are also just weak D type. That one is I still need to work to really merge that, but it shows some issues in the decomp and the order that we do stuff that I will clean up. But that's the end of like some of the backend. Then I need to study how this works with something like assembling and things. But
Great.
generally making good progress there.
You're confident we're going to do it? We're going to be able to remove D type from const.
Yeah.
Right.
While doing this, also found some of the bugs that were there 2 years ago. That was funny. I think const having a D type is too convenient. So there are lots of codes that rely on that. It's kind of nice.
Yeah, no, it's good to get this all cleaned up. Do you know why that's failing?
Which one?
A variable should not be weekends.
I think some of it is probably just stupid test setup, because we do have like variable that's range greater than int32, and if you just say it's int32, it will fail. And another thing that might matter is variable can lower to AL, like address space ALU, in symbolic A range. I don't know if that's this issue, but
Do you want? Should I work on that PR, or is that related to what you're doing?
I mean, it's not really related to what I'm doing. So maybe you can see if the failure is just like test, like bad test. And if you think it's some lowering issue, then I can take a look.
Got it.
So there's a function somewhere that checks if the range is in int32, then stick a int32. Otherwise, if it's too big, give it a int64. Maybe use that. I don't know.
Yeah, I can. I mean, I can just. I shouldn't just hard code int. I should just have it do.
If
based
it's
on what the
not, if it's
minimum
none, then we have a function that checks the range, something like that.
Got it. But do you agree? Like, I see your reply. Like, I think the basic logic is that variables are buffers, and buffers shouldn't ever have a weak type.
Yeah, it's a little bit tricky because it's still, when you stick a const to it, that const is weak type, right? So it's kind of saying you put something in a container that has different D type, but it's probably fine.
Oh yeah, but I mean that should be totally fine. Like we should have D-type broadcasting. You can totally store a weak int to an int buffer.
Yeah. So
I think
yeah, so I think you can just check what's happening in the test, and if you think that something Tinycorp internal is doing incorrectly, I can take a look.
got it. Yeah, I mean I'll also check the min and the max val and promote it if it doesn't fit an int.
Yeah, there are also annoying issues like do we want to do int or uint? Can it be negative and things like that? But int should be fine.
Yeah, I think int.
Okay. Cool. Yeah, so I'll see where I am end of this week. Should be done in this sprint, so 2 weeks. Yeah. Another small thing I was doing on and off was the Python Torch backend, because it's fun to work. Found some bugs and like fix a bunch of small stuff, and now I'm just having like agents pulling random Torch code and see if it works and things like that.
Great.
Also we will get Torch compile soon, so that's also fast, so nice.
Is there a clean way to do that? What do you mean we'll get it? You working on it?
Oh yeah,
or-
so Torch compile also expose something that's lower, and we just hook the JIT to it.
Great. Yeah, I mean it would be great to have Torch as like a real front end.
Yeah. So that's pretty much it. I also step, like some of the slowness are coming from those symbolic rules, those index cooling up, and those like u up given value something. So some of it is really slow and cause a lot of time in Beam. So I will see if I can do something to just mitigate it. I really want benchmark to be a lot faster, not like 30 minutes per work.
Yeah, yeah. I mean we're talking about this. We want all tests really under 3
I think
minutes.
benchmark can be slightly longer, but definitely not 30 minutes per job.
3 minutes. That's it.
Oh, no, because we also beam it. So we can lower that.
Beam just shouldn't be slow. I don't know why it's so slow. All the kernels at once.
even not sure if that's true, but we'll see. Okay.
Oh, if we beam all the kernels at once, it should be a lot faster. If we just compile all the kernels at once, it should be a lot faster.
Yeah, but I think now it's just the Python and rewrite are slow. We still
Sure,
have-
we can improving that is totally orthogonal to improving the packing.
I think now half of the beam time is in some rewrite rules. So there's
Oh,
that.
sure. Yeah.
Well, okay. Let's move on. Slice.
Yeah.
So slice is gone.
Yeah, slice is gone. Yeah, so I didn't end up doing the I talked about this last week, but I didn't end up doing the variable offset. I should look into whether that's easier now that variables are similar to buffers, because that was kind of the thing that was making it tricky. But yeah, I mean, that would make it a lot easier to remove sub buffers in the sense that like you have like a like the actual like underscore offset function in the buffer class. And that would be nice because then CL and WebGPU expose the same API. Yeah, I don't really have much else to say about Slice other than that. I mean, yeah, most of the work gets done in that PM copy to buffer. Exactly, it's called, or wait, I don't remember exactly what it's called. It's some PM copy, something or other.
I mean, if we want to do the variable thing, we have to like improve the SDMA compiler.
Yeah. That's
It's related to Kotlin stuff too.
Yeah. Anyway, that may be worth doing, and I guess maybe is worth looking into if that would be the sort of thing that would help the llama speed.
Is our Gitia CI passing?
It's better than it was. So that's a bit more of what I'm working on.
That link's public.
Yeah.
HCQ2 is failing.
Yeah, that looks like it's running out of memory, which is interesting because when you look in namespace, it does not even remotely get close to 6 gigabytes. So I'm not sure exactly why that's failing. I have to look into that. But yeah, I obviously the QCOM compile only stuff is no longer a platform test. It can now run on x86, which is great, and also can run on my Mac, which is nice. Yeah, I'm looking into doing something similar. So basically, the way I did that was like a little compile server that runs in either QEMU or Docker. And we probably want to generalize that such that you can do this for NVRTC and NVJITlink as well. So that if you're on your Mac and you plug in your testnet and you want it to work with your NVIDIA GPU, then it's not absurdly slow because it spins up a Docker every time it compiles. One thing about that was I was like, oh, I wanted to put everything on Gitia, but that's going to involve pointing a lot of traffic at the Gitia instance if we host the Docker image.
If we host a Docker image for what?
So I would create a Docker image that contains NVJITlink and NVRTC. And then...
Oh, and you want to go to that from...
Yeah.
Yeah, we should probably put a Cloudflare in front of that.
Yeah.
But yeah, we shouldn't be repeatedly downloading stuff.
Yeah, I just mean like everyone who installs Tinygrad.
No, I understand. Yeah, that's why we should put a Cloudflare.
Yeah,
like we should put a Cloudflare proxy in front of. Wait, this is already going through Cloudflare. This might like.
Oh really? Oh.
Get Tinygrad out. Yeah. I mean, ideally, I don't want it to be a separate URL. Ideally, I just want the Cloudflare proxy to be on. Yeah.
Okay, I can double check, but I didn't realize it was already proxied. So if it's already going to the proxy, then it's totally
fine. No, it's not going to a proxy. It's going to a forwarder. Going through Cloudflare, but it's not proxied intelligently.
Okay. All right.
Like, yeah, we would want like some like release URLs to be to hit. I don't know. I'll give you access to the Cloudflare account if you don't have it.
Okay. Yeah, I don't.
But yeah, we gotta get these built into Docker too. No, we don't have to.
Yeah. So I was going to do that first, and that would be like the trial run for getting everything in Docker, and then
right.
That. So then we have these like we're publishing these sysroots, but we're also publishing Docker images. So you can either download like a TarGZ or you can download a like OSTI Docker image. And yeah, that should be good. I noticed.
Well, this I think this can just be a Docker image.
Yes, that one would.
Yeah, this could just a Docker image that can apply the. I mean, I would try to use like Act.
Yes.
I would try to use like Neco's act in the Docker image to pre-download all the dependencies.
Oh.
Yeah.
But why not just like build a Docker image that contains all of the SOs and whatever we need to run?
No, I mean that sounds nice, but the problem with doing that is you want this to work on GitHub too.
Yeah, but GitHub can also fetch that Docker image. It'll just be a little slower on GitHub.
I'd rather just keep both working. But my point is you can use act. It should just read the YAMLs.
Yeah.
You can use act to build the Docker.
Yeah.
Just do one generic setup environment. It'll be like one 20-line YAML file.
I get that, but
Yeah.
it's just gonna produce a bigger image.
Local to the machine.
Okay, sure.
Nothing should never leave the machine.
Yeah.
Right.
All right.
Like we can even have like a job here that actually builds the Docker.
Yeah. That's what I was gonna do, but
If it changes, build Docker.
yeah.
Yeah, I don't care if that. What do we care if that image is 40 gigs?
Okay, sure.
It's not being right?
Yeah. That's fine. Yeah.
It's fine. It's not a problem if it's on GitHub, but it's not a problem. That's a little offensive. It's true, but yeah.
Okay.
Ubuntu is already big. I mean,
Sure.
the default runner image is already like 24 gigs.
Yeah. Yep.
Yeah, we have. I set up our first in the T machines. Tiny T1. T is for Turin. The 128 core CPU. Which doesn't give you as much parallelization as you think, because I think your memory bandwidth bound often.
Mm.
Well, actually, currently the reason this is slow is because we're network bound. Catch all the environment.
Oh yeah. Okay. Well, I'll fix that. I guess I'll look into what this HTTP thing is doing. And it would be nice to have better error messages for that as well. I think we run with actually I don't know. It's getting killed, so I don't know if we can get a nice error message there.
Yeah.
I guess maybe if I disable the killer.
I think we can disable the killer. I think it's
By like disabling overcommit. So then malloc will return a failure case, and then it'll show an error message.
Oh, that's a good idea. Yeah. Disable overcommit is in. Yeah.
Yeah, that's probably what I'm working on this week, is getting this to be good.
Disabling overcommit's a good idea anyway.
Yeah. Yeah, the only thing that's annoying is you disable swap as well when you disable overcommit. Or at least you have to be intelligent about it.
But I won't swap.
Okay, sure.
I'm gonna swap to an SSD and wreck my SSD. If we have to, we can get more RAM for the computer.
Yeah.
RAM's just expensive.
Yeah.
I mean, yeah, we can debate if we want our computers to have 192 or 2 or 384, but
Yeah, I think we'll try it out using 6 gigs per runner for a little bit and see if it causes any issues.
oh, actually, I did 8 gigs per runner.
Yeah.
I did 8 gigs per runner because some of the runners really just don't use 8 gigs. I did 4 cores and 8 gigs per runner, which is the same as namespace. So I don't understand why this is breaking.
Yeah, that doesn't something odd is going on with that HTTP test. Yeah. Comma big model. Yeah, I mean they're running it. And we have our benchmarks. I mean I keep telling them that the way this API boundary is going to look is that like they need to get compile 3 to be very close to what they're doing, because it kind of doesn't work for them to be like putting hacks into their compile model descript and then expecting us to like just know that they hacked stuff together and get it to work. So hopefully this sets up this sort of incentive for them whenever they need to make some sort of change. They actually want to make the change in tinygrad so that we actually benchmark the thing that they care about being benchmarked. But yeah, that's kind of the deal.
Yeah.
I
mean, after HTTP2, I want to just refactor the whole JIT to just be the whole thing they're going to save is just a single UOP.
think that would be nice for
and they need a script that just produces a UOP, and then like we've separated the idea of running from compilation.
Yeah. The other thing they've mentioned is maybe moving away from exporting Onyx and instead having like a runner implemented in tinygrad.
Just does nothing.
Well, it gets them flash attention, right?
Oh. Yeah, I guess.
Yeah.
What, they want to start writing custom kernels?
Yeah.
Oh, wow.
Feel free. They can.
Yeah,
Good luck. More API to maintain.
that's true.
I've been trying to get that delta attention scan thing merged for days. And
Mm.
it's just, we need a scan.
Yeah, but anyway, if they keep saying they want flash attention, that's the way they're going to get flash attention, at least for now. So
They cannot be reasonably blocked by most attention, right?
my impression is that they're not, but I don't know.
Yeah, that's what I mean. Okay. Anyway.
Yeah.
Oh, with new Rangify, we'll have scan for free too.
Great. Even better.
Like it's an explicit scan. It's an explicit scan where you allocate the buffer and store to it. But basically, like you can just write the reduce explicitly in its like buffer store and form in the big graph with new Rangify.
Oh. Okay. Anything else?
No, I think that's it.
Okay. On the RDNA 3, you mean, oh, there's a PR, 17519, fixed core indexing in short schedule.
17519. Zero offset shrink. What?
Maybe I did something wrong. Maybe it's possible to not create this at all.
I'm just gonna merge this. This is fine. I don't think it's yeah, I just merged it.
Anyone want to comment on RDNA 3?
Uh,
Tom saw is bad.
yeah. You want me to talk about RDNA 3?
Sure.
Yeah. So I haven't had much time to work this week. I've been traveling, but I fixed compile times. I got MNIST and Llama running, and I fixed a few more tests. So now I'm down just to the FP16 gem. I found the reason that wasn't compiling was because LLVM does this thing where they explicitly schedule WAMAs in blocks. Because with our linearizer, we place all the loads at the top, which forces all the register values to be live the entire kernel, which is bad. So I wrote like an explicit scheduler. This isn't working fully yet, but it seems to reduce register pressure a lot, such that it's actually compiling. This week, I'm going to try and get that last test passing and also ResNet training, and then probably try to speed up MNIST and Llama a bit.
I see a bunch of other failures on the PR.
Yeah, that's just from the last commit or two because I've been doing some experimental stuff. I probably shouldn't have pushed that yet.
Got it.
Yeah, that's just from trying to fix FV16 gem. Just because there's so many WAMAs in there, it's like I think we're realizing now, or I'm realizing that there's some stuff that happens in scheduling that LLVM's been optimizing under the hood that you don't really realize. So we might have to add some more stuff as we start to introduce more custom backends that
makes
make
sense.
register pressure not so bad.
Yeah, I mean, ideally, you want register allocation and linearization to kind of happen at the same time.
Yeah, because I found
Uh,
like they have a file. Oh, sorry, they have a file that does this thing. It's like 1,800 lines explicitly for WAMA kernels, and they have all sorts of different ways to solve it optimally. This is just a solution I found, and it reduces the pressure of a 64 by 64 gem by like 40 VGPRs, like
Wait, so-
instantly. It's like 50 lines.
Yeah, I don't want any of this. Delete this. I never want something that looks like WAMA schedule policy. Right? That's not the solution.
So
The solution is going to be if you look at you want to use an ILP solver to jointly determine the memory and the register allocation. Like, look at this.
Okay.
Yeah, it's the same basic problem. So it's like, we're never going to merge anything that looks like WAM-A interleave pressure reducer.
Okay.
So I would rather, if it's really just one thing, I would rather just skip that test for the
Okay,
RDNA3 backend and get it merged.
that's what I was wondering. Okay.
I would definitely
It's
rather do
literally
that.
one before that PR. There's one test failing, and it's FP16 gem. I was just thinking maybe that was kind of important because LLVM, they don't have a general solution. It's like specifically like WAMA policies, which obviously if you want a more general solution, that's okay.
Yeah. This isn't. Yeah, let's just skip that test for now and let's focus on actually getting
Okay.
this merged. It's fine.
Okay.
We don't have to worry about that for now. But yeah, no. So the right solution is something that looks like this. There's no way to independently do register allocation and linearization, and it's actually the same problem as memory layouts, right? Because if you execute kernels in a different order, you can reduce the max memory pressure. And we basically want to write something that can just do that.
Yeah. Okay.
How
is speed for MNIST? I think is that probably good. And Llama. I'm going to run them with Beam. I was having trouble running Beam for some reason. It was erroring, but I think it's been working today. So I'll check that.
Great. Yeah, let's
Are you setting ignore beam cache or deleting your beam cache? It's possible you have like
No.
stuff in it.
But it was like giving me some crazy like spamming errors when I was trying to run it. Like it's not that it wasn't running Beam, it was just erroring.
I would still skip the cache.
Yeah.
The cache can be in any
Okay.
state.
Okay. So just focus on get ResNet compiling and check out the speeds. Is that what we're at? I also need to fix tuple order. So
Yeah, I mean, everything should work. And MNIST speed shouldn't be, I mean, the total speed of MNIST should be within 2x of LLVM. Is that true?
Yeah.
And that's with cache disabled on both.
No. Cache level 0?
Yeah, cache level 0. Yeah.
Yeah, okay. I'll run that again. With Beam? Yeah.
I don't care about Beam. Just MNIST without Beam, cache level 0.
Yeah.
Should be let me check out your branch right now.
It's slightly broken. You might have to go back and commit.
Okay, I'll try this next time then.
Yeah.
Go back. I can't. That's not easy to do.
Okay, I'll run it and post it in assembly.
Yeah, right. So if I run Beautiful MNIST right now, dev equals AMD colon RDNA3.
Yeah.
Yeah, you got some tuple order issues.
Yeah, run with tuple order 0.
Okay. Yeah, I think your cache is doing a lot of work. So this hasn't run anything yet.
Yeah.
Okay, there we go. No, it ran the first step. Hey, kernel times look fine.
Yeah, MNIST was pretty quick compared to Llama.
Great. Is this actually working? Yeah, no, there's some like initial thing that's pretty slow, but it might not even be. That just might be tiny red. Yeah, these times look great. Cool. Yeah, so as long as you're within like 2x total end to end for both of those things,
Okay.
for Python time and for model time.
Okay, because so if I take away that scheduling thing, like FP16 gems are just gonna be insanely slow. Like if I'll have to add spilling for it to compile at all, and it's just gonna be a crazy amount of loading.
Yeah, that's okay.
Okay.
Yeah, again, it's never worth merging something. It's
It's a
never worth
specific solution, yeah.
it's never worth trading complexity for speed. And that's basically what that's doing. If you're adding complexity in order to get speed on a certain case.
Yeah.
And the problem is those approaches never scale and always end up being deleted. Oh, yeah, no, this is working. Great. Yeah, and this is working.
Yeah.
The programs look beautiful. Disassembly.
I know. I've been looking at LLVM trying to get as close as possible.
Well, LVM looks ugly. This looks a lot better than LVM.
Really? Which
LV
kernels?
I'm just looking at like a normal, like it's like a normal like conf kernel. I mean, that's
Okay.
just so much more beautiful than like, that is so much more beautiful than what LVM does. LVM like spams crap everywhere.
Yeah, they do a crazy amount of optimization with like SGPRs and
I don't think it's faster.
no,
I
not
think-
really.
I-
Not on most of them.
I would guess that most of those LVM optimizations are just it's just Cruft built on top of Cruft. Oh. But okay. We can this isn't a big deal, but this is an ordering question.
Mhm.
Whenever you don't actually worry about changing this. Let's get this merged.
Yep.
But this is going to be slow because you have V40 dependencies from instruction to instruction.
Okay.
So eventually we'll change that to not we'll put an optimizer in there. But yeah, again, don't worry about that stuff. Let's just get this merged.
Yeah.
Make it as simple as possible. Cool. Go work.
Okay. So for merge, do you want like other models to be fast? What's that look like?
What I want for merge is I don't want there to be any sort of like insane bottleneck except for the one that we talked about on the Gem FP16.
Yeah, I'll clean it up this week then.
But the Gem FP16 should still be correct. It's okay if it's slow.
Yeah. Okay.
Like spilling is okay.
Yeah.
Yeah, we got your stuff shipped out. We got a chestnut and a 96 7900.
I'm very happy about that. Thank you.
Cool. Anything else for the meeting?
I don't think so.
Oh wait, I have one other thing. Can we merge that coalesce PR? Is that okay? Is there something wrong with that?
Well,
Because it doesn't affect the other backends at all. Like I said, it's just their valid buffer sizes. So if it packages them into a shrink, I can lower it easier.
the 6 I'm less worried about than the must divide. Are you sure that's fine?
I'll double
Did
check
you
it.
test this on real hardware?
Yeah, I mean,
outside-
I've run full tests outside my backend. No,
Have you run tests outside your backend?
no, not with this. But I can. I mean, I might have because I've been comparing to LLVM, but I can run a test.
Yeah,
and show it
I
to you.
might have. If I click merge on this, what are the odds that it's going to break update benchmark?
I have no idea. I'll run a test though if you want and post an assembly.
Well, yeah, I mean, like, so understand what update benchmark is, and understand before you ask me to merge something like that whether you think it's going to break it or not.
Okay.
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 Yeah, no, it's just because we don't test on the real hardware. Are those unaligned accesses okay? It's a relaxation of a bunch of things, and that could just break. That could break real hardware.
The 2 LMPR, George, can you review?
Yes.
We don't really need to review now. We can end the meeting first.
Yeah, I'll review them today. I'll review at least expert gating. I'll review GPT-OS is a lot more, but okay, cool.
One more
Okay.
thing. Do we want to tag a release this week?
No. No. Oh, I don't know, but now let's
Yeah, I feel like there's a
release
bunch of stuff
after the CI has been
going
stable, so we
on.
are sure
Yeah,
everything is good.
because originally the plan was to do a release with Chestnut launch, but that didn't happen.
Yeah, it's too late. I don't think now is a good state.
Okay.
Yeah, let's prioritizing making CI and benchmark great, so we are sure everything is good. I don't know, unless we find out having a new release helps the Chestnut customer, then sure we can do a release. Sounds good.
Cool. Yeah.
Okay, that's it for this meeting. Thank you, everyone. See you next week. Bye bye.
Bye.